Okay, guys, welcome to today's Ruby Mob. Last time we left at this was it this one really? Mixing a module into a class, then this bit. No, huh? Up oh. Okay. Hey, no, we are done tackling this. Mixing a module, No. I remember we were talking of ancestors. Really? Oh. Oh, yeah. We were here whereby ah oh, we are done this. Okay. Oh, we were here, yeah. So we were to begin. We were to begin this next session going up the method search with super. Yeah? All right. So as you can see just before here, a somewhat specialized but useful and common technique is available for navigating the lookup paths, which is by the use of the keyword super. So usually, if you have used inheritance before, assuming you are inheriting from a class, actually I can, let me just, so, assuming I have a class A, I have a method greet, then I put as hi and the class. I have another class B that inherits from A. Then I have another method greet. Then I can call super in here and if I create an instance of a class B and call greet, I'm expecting to see hi. So oh, it's he. Okay, so this I've used super just to access I've gone up the method lookup. So instead of using the greet in the instance in the class B, I'm going up by looking at the greet method in the superclass of class B. So in this case, you can see it returns the result of calling the greet method in the class A. Okay, so assuming this case now we are using, this case now we'll be working with the modules. This case now I will be working in module. So the following listing shows a basic example, after which we'll go to the why will you do that aspect. Okay. So using the super keyword to reach up one level in the lookup path. So we have a module M. It has a report method, and that is its output. Then we have a class that includes the module, and it has the method report, which is with that, then outputs that, then super. So in this case, super goes up the method lookup by looking at after this report is an instance method in the class C. Up the method lookup, we notice that okay, before I come here, we are creating an instance of class new, then calling report. So we saw that when we use include, or the way method lookup will go in this case is after it will first check if the report method is an instance method in the class C, check for included modules if it's in the included module, then check if it's in the super class of class C. So in this case, we want to go up inside the report, up the lookup path from the instance method here is to go to the module. So, okay, let me have module X. That has a method C. Yes. Hey. Hey. Okay, whatever that is. And then we have, so we have that module, then we have a class. Let me call it Y. It includes module X. Then we now have a method sing in here. So with the method sing, first let's put just to differentiate with that, I am in the class. Then put as yeah, there is no more over here. Okay, what happened? Oh, yeah. Oh, then now I can go up the method lookup by using super. So this, we'll see the effect of that. I end the class. So in this case now, if we instantiate the class Y, then call sing, we're expecting to see first sing will go into being is an instance of Y, it will go and check if sing is an instance method in the class Y, and it will find sing. So it will start executing it. Yeah, we'll execute this, print out that. Then super now goes up the method lookup by now looking at, after looking at the instance method in the lookup path, we usually go to the module. So now in this case, calling super here now, we'll go to now the method in the lookup, or the method in the module, and that method is sing in the module X, and it should output this. So first we're expecting that, followed by this, then that. Yeah, Getty, am I okay? Any guesses? I may be cheating you guys.
I think if you output
Okay, why?
because
Oh, hold on.
Sorry?
It will only output Mawawa. Only?
Yes.
Okay, and why is that?
No, actually, on second thought, it will output the first, the I am in the class,
Yeah.
and then normal or him. Then
Okay. Yes. So I'm in the class Y, but there is no Mawawa here. Then finally there is Mawawa there. Okay, interesting. Okay, and that's the super keyword logic there. Any questions? Get yes.
so what if
Yeah.
we have uh, we have a module?
Mm-hmm.
Okay, we're including a module into our class,
Mm-hmm.
and then inside that module is another module. Is that possible?
Yeah.
Then we want to call super on the other module. How will we call the super of that's
That's interesting. Let me exit this. Then FG. Okay. So, it's like we have a nested module. Let me call it P. So you're saying inside this module there is another module.
we can have that module to have any method.
We can. Oh, this module should have a method. Okay. Uh huh.
And then we have another module.
Inside here.
No,
Oh, this is a module on its own. Then you have another module. Here. Yes.
it includes
Can we include?
also this module has a method with the same response.
Okay.
And lastly, we have
Mm-hmm.
we're,
Ahmed, we have
we're including the module Q.
only the module P. The module P or Q? Interesting.
Then we have also have the same method. Each we can call super. No, actually, this is where my question comes in.
Okay.
We want to call module P. I can hear myself someone saying, I'm getting here. We want to call module P.
Actually, I'm not. You can use. Okay.
So when we use super here,
Mm-hmm.
we'll call module Q,
Yeah.
right? But I want to call the method that is the
You
module
want to
Q.
call this one? You want to call this?
I want to put yay.
Oh.
Yeah.
Hmm.
So I'm wondering if we could use super super. This is super.
Okay. Super, only goes one step high. Okay, let's see. If we do only do this, it will only output that, yeah? But going up now, How will it go up?
You can do super.
Nah. Because if we do this and create an instance of class new and call get expecting I'm in the class and her which is here. But you wanted to reach here. But super only goes once. So even if you add another super, it's just like you're telling it that from where we are, just go up the method lookup.
And super.
Is there a thing like, okay, let me reopen the class. Include queue. Let me have, so you're saying super.super. What does this, let's see.
I'm using the assumption that
Yeah.
I'm calling methods that have already been defined somewhere.
Okay.
So always call them without specifying anything. Like if I was calling the method getty inside this class, I could have only written getty.
Okay, let's see. Define method super funnel class in Getty. Because the moment we do super is only one keyword. It's like if you have a keyword, is like if you combine something like if is a keyword. So it's like you can do something like this. Which other keyword do you have? Even include itself is a keyword. So it's like you may be doing something like that. Putting a keyword on a keyword. But because what the keyword super itself does is going up the method lookup. Because the way we could have let's see, if we do q has, wait, let's be, let's see, dot getty. Did you mean, oh, I'm trying to, oh, seems with super we cannot access it the way you are, yeah. Okay. So in this case, you can see the output was report method in class, followed by about to trigger the next high up. Then super will go up. Method lookup is the method inside the module, which is this. So that is the output as you can see here. Then the execution continues. So this section they're explaining now. An instance of CNAMELY C receives the report message. Yeah. So then the method lookup process starts in C's class, and C's class is this. And sure enough, yeah, there is a report method. So this method is executed. So, but inside the method, there is a call to super. So that means even though we found the object, even though this object found the method corresponding, it must keep looking to find the next match. And so if the moment we use super, we are going up, which is looking the next match of report, which is inside the module. So in this case, so if for assuming, so it's like if there was if we did not have a module M, if we did not have a module M, the next method lookup will be in the superclass of C. Yeah. So, and that is what will be executed. So, not the report method in the module M. It will have been the first match in the search for a report method if C report didn't exist. So it's like if this wasn't there, then the search would have gone to the module. That's why now super goes next to the next part it will search for report is in the module. So the super keyword, it gives you a way to call what would have been like the applicable version of a method in cases where that method has been overridden, maybe later in the lookup. So sometimes, why will we really use this? So sometimes, particularly when you're writing a subclass, a method in an existing class does almost, but not quite. Yeah, it does almost, but not quite what you want. So with super, you can have the best of both worlds by hooking into and wrapping the original method. So assuming this method was overridden, as you can see here, but we don't want this version of the overridden method. So we use super to go up the method lookup path. Okay. Let's see this other example. We have a bicycle class. With attribute reader, we have gears, wheels, and seats. Then we in our initialize method, we have wheels. So every time we are creating a bicycle object, the wheels are set to 2, seats 1, gears set to default, which is 1. Then, okay, let me just do this. Let me have it here such that you see what really happens. Have the class bicycle. Then, we have now the tandem that inherits from the bicycle. Yeah, so we have this here. So with this initialize method, it means when we create an instance of bicycle, so actually .new usually checks for what .new usually does. When we call .new, actually it usually searches for an initialize method. If it finds it, then if it doesn't find it, you usually get just an object. But if it finds it, like in this case, you have an initialize method, you'll notice we'll have the object and this set just by like what I'm saying here, these ones. But usually if you create a class that doesn't have the initialize method, we usually only have that, that object reference. But this place, we are every time we create an object, we are setting the gears at seats and wheels. Same to the tandem. Though this time round, with tandem, notice the initialize method of tandem first is super. So super first we go up the method lookup, and the method lookup in this case is the super class. We don't have modules in this case, and we don't have any included module in the tandem class. So the next lookup path will be in the bicycle class. If you go to the bicycle class, the initialize method, as we are seeing, has these. So if we create this, it will first create set that wheel, seats, gears. But we have our seats now being set to 2. Yeah. So it's like we are overriding the seats. We're only overriding the seats, but the rest are. Okay. Oh, Oh, when we call initialize method, you have to pass. It is not. Oh, in this case, we had gears, the default value being 1. So that's why you can see this one here. But if we call tandem, we have to set the default value, because the initialize method in tandem takes arguments. So as you can see, wrong number of arguments. We gave 0, but the method expects you to pass at least, or let me say, it expects you to pass 1. Okay, you can see now, we passed the gears, we passed 5, so that's the value of gears. The seats, in this case, we are overriding the value of seats, though in the initialize method it was 1, but here we are overriding the seats to 2, and wheels remained 2. Okay, any questions, Getty? Okay, so Super provides a clean way to make the tandem almost like a bicycle. We change only what needs to be changed, which in this case we are just changing the number of seats. And Super triggers the early initialize method, which sets the bicycle like default values for the other properties. So it says the others, but the only value we need to change from the initial one was only seats, which you saw it changed. So when we call Super, we don't explicitly forward the gears argument that part. So what was happening here? So if I call Super here, it doesn't mean that now it, because notice in this case, you can create a new instance of the bicycle class. Yeah, we can just, this is a default value. So it's either, if you don't give it, it will take, it will, the default is 1. Gears is 1. But if we, let's say gears, okay, let's pass 4. You can see this time we have not used the default, we have used 4. So this time gears is 4. But so what they're trying to say is when you use Super, it does not mean that the method will be like going up the method lookup with the whole method plus the arguments and stuff. Notice here, the argument is optional. If you don't give, we have gears set to 1. If you give, then gears will change. But in this method here, you must pass arguments. It's a must. So using Super does not mean like we are carrying like this method, we're executing the whole of it here. It actually Super only looks for that. Then the initialize method, it only looks for the initialize method, but the argument parts now depends. For example, in this case, initialize method here, we have to pass the arguments. But in the Super, yes, we have an initialize method, but it has a default or optional, let me say. All right, so when you call Super, I don't explicitly forward the gears argument that was passed to initialize. Yet, when the original is called, any number of arguments, any arguments provided are visible. So this is the special behavior of Super. So the way Super handle argument is as follows. So call with no argument list. So when you call Super with an argument, as we have done in this case, then Super automatically it forwards the arguments that were passed to the method from which it was called. So if we call it like this, then it will forward the arguments. Okay, but when we call with an empty argument list like this, Super sends no arguments. to the higher up method. Even if so, we can always try out that. So let's let me open the tandem class. It was inherited from bicycle. Then we have the initialize. That was taking syntax gears. But we want to, we are calling super with empty arguments. Yeah. Then maybe let's override the wheels. So at wheels, and so let me create a tandem object. So what happens? You can see in this case, if we call it super sends no arguments to the higher method, even if arguments were passed to the current method. What are we expecting actually as the output getting?
We are expecting it to output what is in the bicycle class, which was initially 1. It will output 1 for the gears, also 1 for the seats, and 12 for the wheels.
So if we do like this, actually, it's like you're telling it, don't use this, don't even use this default. So yeah, if we put it like this, actually, we are not even telling it to use the default at this case. So I'm expecting wheels to be 12, seats to be 1. At gears, I'm not expecting 1 because we have, it's like you're telling it, don't use this one.
So it will be an error.
Actually, will it be an error? Probably. Will it be an empty array or 0, or will it really be an error? Let's see. But I'm not expecting a 1. Yeah. Argument, wrong number of arguments given 0. Oh, our tandem method expects that. So, oh boy. Expects gives.
Yes, is 1. Seats is 1.
So yes, get what really happened here.
So I think when we call super here, you see this last code that you mentioned, where tandem inherits bicycle. When we call super, it goes and collects all the last wheels, the values for wheels, seats, and gears, and then checks upon what it has. So in this case, it has wheels, which is 12. So gears will remain 1, seats will remain 1 because these are the values. And then since we override the wheels, it will remain 12. But I do not understand why it has not taken.
Okay, let me go back to the. So we said if we call super with no argument list, then super automatically it forwards the arguments that were passed to the method from which it's called. So what we did up here, it forwards these arguments. So that's why we were getting gears to be 1 here, yeah? Higher. Then if we call it now with an empty argument list, super, it sends no arguments to the higher up method. Even if arguments are passed to the current method, it doesn't send any arguments to the higher up method. So even if we pass whatever here, it doesn't send these arguments to the higher up method, which is this. Notice in the initial one, it forwards the argument. So default value, when we use this, it forwards the arguments such that if you change, default is 1. So if you change the value of gears, then it will set gears to 1. But in this case, even if we pass this, it doesn't forward the arguments. As in that, what that just means is that the initial, these arguments are not forwarded to here, so it will always remain the default gears to be 1. So here you are still just expecting gears to be 1, seats to be gears to be 1, seats to be 1, and our wheels to be 12. Then the third one is when you call with specific argument, for example, ABC, then supersends exactly those arguments. So if we let's create it here, and them. Inheriting from Bisco. Initialize. Yeah, then it takes, we have a gears wheels and seats. How about to give it 6. Then we call super with the gears or with the seats and gears. Oh, but you have to set this value. So seats, let's say they are 32 and really? Okay, let me leave it like that. So what will happen in this case? Wrong number of arguments given. It should have something. So okay. Is it using the, is it really reopening this one? Because when we call it with that, then supersends exactly those arguments. So like it will go to the initial, like, okay. Let me call it once more. The initialize method, but this time super. Okay, let me add gears and wheels, and then call create an instance of tender. Call new. Let's see the error first. Given 0, expected 1. Then we pass something. A wrong number of arguments. Given 2. Okay. We have given 2. Expected either 0 or 1. Oh, so this is brought by what we have done here, because it has gone to now the super, which is the tandem. Where is it? Okay, back to the bicycle. So in this case, it finds that here we can either have 0 or 1, but in our super we have given it 2. Now it's bringing an error of wrong number of arguments. Get any questions up to here? Okay. All right, so this unusual treatment of arguments exists because the most common case is the first one, where you use just super with no argument. So where you want to bump up to the next time method with the same arguments as those received by the method from which the super is being called. So that case is given the simplet, you just type super. So, and because super is a keyword rather than a method, it can be engineered to provide a special behavior. So now that you have seen how method lookup works, let's consider what happens when the method lookup fails. So what usually happens when now maybe it doesn't find maybe the method you're searching for. So next up we'll look at method missing, which will talk about what happens in the method lookup when the method, there is the method lookup fails or the method is missing. Okay, guys. Thanks for joining us today. That has been the mob. Next time. Adios.